Hello students, welcome to JEE English by Unacademy, India's leading learning and test preparation platform. And guys, we have made this JEE English channel for you so that you can learn everything exclusively in English. And guys, we have got best in class educators who have graduated from IITs, and we are going to make sure you get every basics and depth of any topic. And we are going to work hard for you guys. Subscribe to our channel and click on the notification button to get timely notifications. And guys, today we are going to go through kinematics, one of the most interesting topics of physics. In fact, kinematics carries a lot of weightage in your exam. Not only that guys, kinematics is very useful in real life. You can make use of it to develop applications or even take advantage in your sports. You can improve your sports, you can improve the way you run, and not only that, you can develop products, you can develop technologies. Kinematics is everywhere. And today, we are going to tear it apart. I'm going to take you through the bits and pieces of kinematics. And guys, a little bit about myself. I'm Murlidharan. I am an IITian. I have 4+ years of teaching experience and preparing students for IIT JEE. I have filed 18+ patent applications in India, US and Canada. And today I am over here so that I can teach you physics and make sure that you understand physics and make sure you become passionate about physics just like me. And I want to make sure that you get better than me. And guys, we have something interesting for you. That is our Unacademy learning app. You can download our app on Google Play Store or App Store. And you know what? We have special live classes on this, which is delivered by our top-notch educators. Not only that guys, if you want to go for something for your test preparation, we have our subscription platform. You can go and get our subscription. You can go and get, specifically if you want to prepare for IIT JEE or any other exams like NEET. And if you want some discount, you can make use of my coupon Murli Live and you will get a 10% instant discount. And guys, if you're in 9th or 10th or 11th class, I would recommend going for 24-month subscription, which costs 1,500 per month. And if you're a long term or a dropout, you may want to get a 12-month subscription, which costs 2,500 per month. If we are in a lockdown and if you want to get something for a 2020 target, you may get a 1 or 3 month subscription. And guys, we have best in class content with best in class educators. We also have DC Pandey on our platform. So guys, we are going to get into kinematics now. These things apart, kinematics is very interesting than anything. You know what? And for working around kinematics, there is something known as vectors. We need to know vectors because kinematics is about motion. To understand motion, we need to understand direction. To understand direction, we need to understand vectors. But before we get into vectors, we'll get into scalar. So what's a scalar? Scalar is something that can be measured on scale in a simple term. And scalar has like a magnitude. It's a physical quantity that has a magnitude and it has a units attached to it. For an example, mass can be expressed in terms of kgs, 10 kgs or something like that you say. And speed, you can express it in terms of meters per second. Distance, you say 10 meters. Again, it has magnitude and units. And scalar only, expresses value and it does not talk about direction. So using scalar, you don't need to, know about the direction. So you don't need a coordinate axis. So coordinate system does not matter. And not only that guys, so there is something interesting about scalar. Scalar can be both negative and positive. I mean both negative or positive. So guys, this is something very important. You need to know scalar can be negative. Just remember this. And there are many scalars that we'll see in the coming classes or even in this class that is negative. Of course, we are going to see, in a few seconds. And scalar can be product of two vectors. Okay, scalar need not be necessarily a product of scalar. It can be also a scalar product or a dot product of vectors. And scalar, like I told you, is something that you can measure. You can measure it on a scale. Like time, I can measure it on a watch. On a weighing scale, I can measure, mass of a body. Something like that. And now, we are going to talk about something that is going to confuse us a lot of time. We get confused a lot of time in our exams looking at some problems like this. And this is like the brain teaser problem. Confuse me challenge. Problem number 1, which says which of the following can be negative? Mass, distance, velocity, work done. So what do you think? Mass, no. Distance, no. Of course you know that. Distance, no. It's not displacement. Velocity, it's a vector quantity. It can be negative. And what about work done? work done also can be negative. Remember this, guys. This is very, very, crucial to remember that work done can be negative. Okay. Now, problem number 2. Which of the following are scalar? Work done, potential energy, velocity, distance. So, work done, is it a scalar? Yeah, it's a scalar. Work done is a scalar. What about potential energy? It is also a scalar. And vector, of course, like velocity is a vector. So, you need not worry about it. Distance is a scalar. Which of the following is a vector? Speed, distance, weight, work done. Speed is not a vector, it's a scalar. You have something velocity, so speed is, not a vector. Distance, not a vector. Work done, not a vector. We just spoke about it. It's weight. Weight is, the force on a mass by the gravitational pull. So the gravitational force is applying this, pull. Hence we call this a vector. It's a vector. Weight is a force, so it's a vector. It's as simple as that. Now, next question would be like, what is vector? So, vector is no different than a scalar, but it has a direction which makes it explicitly stand out apart from the scalar. And this direction is very important when you are talking about motion, kinematics, dynamics, etc. And even in electromagnetics, vector is very useful. So, understand this concept very, very, critically and carefully. Now, you can think of vector as something that is a scalar that has, like a magnitude and a value to it with a direction. You see in this case, this thing is rotating with a specific direction. So, this is a, has some vector to it. And in vectors, you need a coordinate system, you need a reference frame, else you will not be able to define a vector easily. Imagine that we are in a space, like, you are alone in the space. There's nothing around you, you are in a vacuum, there exists nothing. Can you assess the direction? Like in a blank space? Probably not. Because you need a relative thing. You need at least an earth to say that you are this many meters away from it. But whereas in scalar, you can say that, I've traveled 10 meters in this space. Still it makes sense. And what about different kinds of vectors? Velocity is a vector. Displacement is a vector. Force is a vector. Momentum is a vector. Fields are also a vector. And vector can also be, this very well I know, can also be both negative or positive. And in vector, you're measuring everything relative to something. You need to, grab this concept right away that in vector, you're measuring something relative to something. And vectors are expressed with not only magnitude and units, but with direction. So these three things are very important. If someone asks you, how do you express vectors or what are the things in vectors, then it has magnitude, direction and units. You should not even forget one of that. And now guys, we have been talking all about vectors and vectors. So how do we represent this vectors? Like how do I know whether it's a vector? So in a vector, you typically represent it with a little arrow on the top. And like this R you see over here, there's a little arrow on the top. You see this V over here, a little arrow on the top. This may look like force, F vector, that you may call it like, a vector. And E, which is also a vector. Looks like a field, isn't it? And now guys, vector needs a coordinate system. You must be clear about it. And vectors, how do you represent vectors? Vectors must also have some units, units to it, right? And in this case, we are making use of I cap, j cap, k cap. So you make use of this unit vectors to represent vectors. How do I say this is this many, like just telling this many meters away from it? It does not tell me anything. But I need to know the direction. I'll make use of unit vectors and add some value to it, and then it will tell me every direction magically. So that's how we represent vector using some unit vectors. And in this case, we are going to specifically look at I cap, j cap and k cap. And you know what? Unit vectors are unit vectors. They have only unit of 1. Like value of 1. It's a unit vector, magnitude of 1. That's it. And in unit vectors, they are generally perpendicular to each other, or they cannot be represented in the same direction. Else, you do not need 2 unit vectors, right? In this case, I cap, j cap and k cap, there are like these 3 unit vectors. They are perpendicular to each other. So in a unit vector, you basically cannot use them to represent the same direction. You need 3 unit vectors to represent 3 different directions. That is the main use of unit vector, and more importantly, you can represent any vector using unit vectors. And guys, we have talked about unit vectors. We have also talked about vectors. So what is the difference? How do I know whether it's a unit vector, whether it's the unit of that vector, whether it's a thing, how to represent a vector? So we make use of caps, a little at on the top of them, to represent a unit vector. If you see a little at on the top of them, then it's a unit vector. And now guys, what we have been talking all about this vector, but it needs a coordinate axis, it needs something, it needs a relative frame or something. How do I represent a vector? So in our case, we are going to talk about 2D, systems like x and y axis. So we are going to make use of 2D Cartesian coordinate system. And you see this thing over here, there is this I cap, which is unit vector along x axis, and this j cap, which is unit vector along y-axis. You see this minus j cap, which is unit vector along minus y-axis, and minus I cap is also unit vector along minus x-axis. So why am I specifically talking about plus I cap and minus I cap when they are representing both the direction and x-axis? Actually no. I is in plus x-axis and y is in minus I is in minus x-axis. So they both have different directions. And j cap is also another unit vector, whereas minus j cap represents its opposite direction along y-axis. And unit vectors have a magnitude of 1. You need to remember this. And you know this, I guess, by now. You must have understood it. And now the thing is, we have been talking about vectors, unit vectors, unit vectors. So what about a point on this Cartesian coordinate system? We have been doing all this for, representing a position. In this case of position, we will also represent velocity, force, everything using this unit vectors. But now let's understand how do we represent a particular point or a vector on a coordinate system. So when I'm talking about coordinate system, like it involves some sort of like a graph or something where I'm able to plot a point. In this case, here's the, like r vector r at this position. How do I determine the position of r? So here it's given the value of r is minus 4i cap plus 3j cap, which means it is minus 4 units to the left of x-axis. Okay, it is minus 4 units along x-axis and it is minus 4 units away from y-axis, and similarly 3j cap tells me it is 3 units away from x-axis. This is a critical point that you need to understand, that this vector 4i cap plus 3j cap is 4 units away from y-axis and 3 units away from x-axis, whereas the value is, what is the value? Minus 4i cap plus 3j cap. Okay, and now guys, why am I talking, like I'm saying that, it is to the left of x-axis? Why don't I just say x-axis? Because sign matters and the distance it is from is in the negative, along the negative x-axis direction. So this minus has a significance because the direction would change if I just didn't say the minus. Okay, the signs are very important in vector. And you have seen that now how are we representing this vector? Using this unit vectors i cap and j cap. So what about, the position of this particular point? I could say, it's like 5 units away from origin because we are measuring everything related to origin, which is 0, 0 on this graph. But how do I know it is in this direction? And what is, like the magnitude? Magnitude, I can calculate it using hypotenuse theorem. As simple as that, because these two are perpendicular to each other. So it would be an hypotenuse theorem to calculate the magnitude of the position of this vector or this position of this point on this coordinate system. But we are talking all about this. How do we do that? Simply draw, like a triangle, a right angle triangle with 4 units along x-axis and 3 units along y-axis, and then you find out the unit, like the unit of, the distance from origin. It's really as simple as that. But this alone does not tell you anything because there are infinite such 5 units on this axis. So you need to critically understand that the significance of this representation minus 4i cap plus 3j cap. It is 5 units away from origin, but the value of vector is not 5 units. The value of vector is minus 4 I cap, which means it is minus 4 units along x-axis or minus 4 units away from y-axis. You can say it better as like to the left of y-axis, and it is 3 units away from x-axis. So that specifically tells me the direction to travel to get to that point. And that's why we call it, it has a direction and everything. And that's the significance of using the I cap and j cap, so that I can exactly represent the direction. And we have seen how to find out the the distance between origin and R. But what about if I have two, points in this graph? Like I'm a layman, I do not have anything. I know I have understood this concept of vector, and it's very easy, I can do everything in I cap, j cap. But what if I have 2 points and someone just gave me a graph and told me just measure the distance between them? It would become very, very tough for me. Now what would I do is simply, I would make use of vector to do it. See, there are these 2 points over here. One is the position of vector A, which is for minus 4 I cap plus 3 j cap, just like the R cap that we saw before, and B, which is 6 I cap plus 8 j cap, which means it is 6 units away from positive, like in the positive direction of x-axis to the right of it, and 8 j cap means it is 8 units away from x-axis. So now to find out the distance, I would do a very simple thing. I would subtract it. That's the easiest way to do it, right? Rather than drawing a graph and measuring each of that, squares, it's easy to do, just subtract them and find it out. It's as simple as that. I do not have a scale, I'm a layman. So this is the easiest method to do it. So you basically subtract these 2 things to find out the distance between 2 points. And I cap and j cap are 2 different things. That means they have a unit attached to them, sort of like a unit attached to them in the x and y direction. So what I've done is a minus b to find out the distance. As simple as that. It is minus 4 I cap plus 3 j cap, which is the value of vector A, and 6 I cap plus 8 j cap. Which means it turns out that minus 10 I plus minus 5 j cap. Minus 10 I cap minus 5 j cap. Now I have found out this vector, but I was talking all about distance, and distance. How do I find the distance? Okay, what I will do is I will apply the same hypotenuse theorem and as well apply a mod to it. Like not just the hypotenuse theorem, I will apply a mod to it because distance cannot be negative, because I am talking about that length, that positive length is the distance. So I am going to do that to find it out. So once I did that, minus 10 I cap and minus 5 j cap, I know that the hypotenuse is going to be 10 square plus 5 square under root of 10 square plus 5 square, which is nothing but 5 root 5 or under root 125. So now we found the distance between these 2 positions or these 2 vectors, but you know what? You don't know still the direction. It's only like 5 root 5 units. So how do I know if I have to commute from A to B or B to A? How do I find out in which direction I have to move? We actually sort of already know it, but we'll have a look at it. So if I have to find the direction, then it is talking about displacement. Okay. So let's say I have to move from point A to point B. Then what I will do is simply, I want to move from point A to point B, where the final point is B, like the final position that I need to get to is B, and the initial position is A. That means I need to subtract B from A, final from the initial, because I have to move in this direction, right? Not B to A. So I have to subtract B from A. That is B minus A is what I would do. And I'm getting, plus 10 I cap plus 5 j cap, which means if you do this, you'd get that, right? 6 minus of minus 4 is plus 6 minus of minus 4 is 10. And 8 minus 3 is 5. Now, the thing is, I know it's 10 I cap plus 5 j cap. That means I have to move again 10 units along x-axis and 5 units along y-axis. That is positive x direction. 10 units along positive x direction and 5 units along positive y direction. Just like how we did before. And now, what about if I have to move from B to A? I have to do the reverse thing, right? Like I have to basically subtract A from, because A is the final point in this case. I'm moving from A to B. This is the direction that I have to move. This is the direction that I have to move. That means I have to subtract A from B. And I found that it's minus 10 I cap, minus 60 I cap. Isn't that correct? I'm moving along minus x axis and minus y axis to get to A. Isn't it? So it's as simple as that. And now you understood that, until now we are talking about vectors as displacement, and still displacement didn't give us the exact intuition of vectors. But now you understood it well that vectors have a direction. Because even though both this vector b minus a and a minus b have the same value, but they are not the same thing. You cannot, say that they are the same thing. So a minus b is not equal to b minus a. In fact, a minus b is equal to minus b minus a. And this is it. So this was as simple as vector, but how about, I want to calculate, distance between these 2 points. There is another little complex way where I would write ax is equal to minus 4 because it was minus 4 units away from, y-axis, and bx is equal to plus 6, which means the point B was like plus 6 units away from x-axis, which means the distance, x distance between them is like 10 units. And similarly, I do it for y, which means like, plus 3 and bx is equal to plus 8. Now I know the distance in y-axis direction is 5 units. And I would find an hypotenuse, which is little bit complicated to do. Now you understood that vectors is an easy way of solving problems in physics and many other aspects of, physics. Now the thing is, we need to understand something more, which is very interesting. How and where do we use this coordinate system and vectors? Guys, in PUBG or any other, dynamic game, there is vectors and coordinate system involved in it. You cannot move in that direction, right? Like your character cannot move in that direction. So there is always this coordinate system and vectors involved in them. They're heavily involved in them. And some other thing interesting, that even if you're not a game freak, there is something that is there everywhere and you're not noticing it, that is using coordinate system and vectors. That's navigation system, guys. Your maps make use of coordinate system and vectors. Like your Google Maps, your Apple Maps, even when you're ordering food from Swiggy or Zomato, or if you have booked a cab on Uber or Ola, still you're noticing, things like that. Like, there is a navigation, it is telling me, exact distance that my food is there from being delivered. So there we are making use of coordinate systems, and you understood that this is very critical in life, like, for developing technologies. Now we are having navigations and everything using this vectors and coordinate system. And similarly, you have seen before, you can also play, freaky games. There you're also playing freaky games where they're making use of this coordinate system vectors. Now, can you use it somewhere, not, technology, but in real life to make things better? Of course, guys, like you must have played cricket or soccer. There we are making use of vectors and direction. If you understand vectors, direction, kinematics properly, you'll excel in your sports, you'll excel in your games like no one else. It's simple techniques that you need to improve to do it. If you know the right direction, for an example, this cricketer over here knows the right direction to hit the ball so that his ball does not get caught and crosses the boundary. Like, it's the highest run that you can score, right? It's really that simple. Even soccer is something like that, where you can make use of this kinematics and direction to make your real life more advantageous. Even you can run faster if you understand, everything like this vectors, coordinate system, and kinematics. This is the beauty of physics. You can apply it in your real life. And the beauty of kinematics is, it is very much related to a real life. You can correlate the things with you, as and when you keep understanding the concepts. Now the thing is, guys, we know that, there is coordinate system, but we need to know when did this evolve. But this didn't evolve very, early. Imagine about those days where we didn't have, like Cartesian coordinate system or coordinate system, X and Y, Z was never accepted. People didn't understand it. Back then we used to make use of body relative direction system. So you would measure everything relative to your body direction. So for me, left is left, right is right. It is, it is absolutely right and left for me. And front is front, back is back. So in body relative system, you're going to make use of your directions with respect to your body. But now the thing is, like body relative system has disadvantages. Like left for you is not left for me. Because I'm standing in front of you, left for me might be different. So there is coordinate systems like Cartesian coordinate system, polar coordinate system, cylindrical coordinate system. But what about navigation? Back then when there wasn't technology, there was like cardinal systems. The thing that you measure on, like your compass or sometimes even on your maps. It tells you about the north, south, east, west, right? That's the cardinal system. And these cardinal systems were used for navigation back in the days. Like if you're struck somewhere, you're going to make use of the North Star to understand things, because North Star's position generally does not change. Actually, it does not change. It's a Polaris star. So I was, finding this North Star to do things. And like this entire cardinal system evolved around this North Star. And even on your compass, it gets, like the different, like magnets on your compass get attracted to that particular poles. Using that, you will be able to navigate. So cardinal system has north, south, east, west, just like how you say the directions. And cardinal system is an absolute system. North is going to be always north. The North Star is going to appear in the north. And sun rises in the east and sets in the west. These things are not going to change unless your earth starts rotating the other way around. But anyway, so now the thing is, when we're talking about cardinal system, we need to understand the cardinal systems. But before that, we'll get into something interesting. Is time a scalar or vector? Time actually has a direction, doesn't it? Like you're talking about time all the time, even when you're watching this video, or even when you're doing something, when you're going to school or when you're going to office, like time is moving. Even people say like the time is flying. But the thing is, time has a sort of a direction, but it cannot move in backwards. You wouldn't say minus 10 p.m. I moved in minus 10 seconds, or I have lost minus 10 seconds, makes sense. But anyway, it does not move in backwards. But like, even though this time has something like directions and a measurable quantity, it's not a vector. And for your exams, guys, time does not have a direction. It is anyway scalar quantity. And this theory of time having a direction was conceptualized using a theorem known as one-way direction or arrow of time. Like one-way direction is the method used for it, and arrow of time was like a theorem used for conceptualizing this one-way direction of time. One-way direction, isn't it? Moving in one direction. And in relativistic mechanics, we are making use of this time as one of the coordinates. Like you see x, y, z, and we also have t. So this is a specialty of time. But time is not a it's not a vector quantity, it's a scalar quantity. It's a scalar quantity and it does not have a direction, a definite direction, because it is not negative. I can't say, I can't specifically measure the direction. But now we have been talking about cardinal systems. Let's go into the cardinal system first. Let's understand the convention of cardinal system. When cardinal systems evolved, the first thing was like north, like using compass, we were able to measure the north. So we made use of compass to measure this, cardinal systems initially. So on the scale, what we did was we calibrated that north as 0 degrees or 360 degrees. From there it goes 90 degrees in the west and 180 degrees in the south and 270 degrees in the west. Okay, but you don't really need to know this. Okay, all you need to know is like, north and south are 180 degrees to each other, and east and west are opposite to each other again, and north and east are perpendicular to each other. Why do we need to know this? You may get your problems in cardinal system. And of course, it would be useful to know this as well, like, for your real life applications, understanding things where you're lost, you do not have an access to your GPS or something. You can make use of cardinal systems to reach the place. But now the thing is, like, how do we represent it on a coordinate system? Because we are so much used to coordinate system. We have been learning all about this coordinate system graphs since our childhood. So how do we represent this cardinal system on a coordinate system that can make our life easy? So you see this guy running towards east. He's running towards east is the plus x direction. And this guy is running towards north. That's the plus y direction. And the opposite, that is moving towards west, is going to be minus x direction. And moving towards south is going to be minus y direction. So east is moving towards east is plus x direction. Moving towards, north is plus y direction. And moving towards west is minus x direction. And moving towards south is minus y direction. It's also intuitive if you keep this compass kind of, design in your mind, that east appears to be on the plus axis and north appears to be on the plus y axis. Okay, now we are going to make use of this to solve some problems. But before that, we'll have a look at also body directions in terms of XYZ. As body directions are generally never, universally used. But if at all someone talks about body directions, you can give it a convention, like right is plus x-axis, left is minus x-axis, towards up or forward is like, plus y-axis, and downwards is minus y-axis. So this is something that you can do to understand even body directions, and you can represent it in like Cartesian coordinate system. Now the thing is, we'll have a look at little bit of, what is like distance and displacement. So what is distance, guys? Distance is basically this total length. So let's say there is like, a school student or yourself who has thought, today I'll go to grandma's home before going to school. You just went to your grandma's home. Then you went to school. And then you went back to your home directly. Now the distance between your home and grandma's home was 4 meters, the shortest distance. Let's assume in this case the distance that you traveled. And from grandma's home to school was 3 meters. And then from your school, like let's assume it's both perpendicular, which may not be true, but then it would be like 5 meters. Now the thing is, how much distance you have traveled. You basically traveled 4 meters when you're going from home to grandma's home. And then from grandma's home to school, you have traveled another 3 meters, that is 7 meters. That is the distance already you have covered. When you're going back home from school, you have again traveled 5 meters. Okay, that's going to be 12 meters. 5 plus 4 plus 3. But now when we're talking about distance, we're taking all absolute values, right? It's the total length like that is covered in your path. So whenever you're walking, you're covering distance, you're not covering displacement necessarily. When displacement can be defined by, direction and the shortest path, but most of the time we're talking about distance in our real life or in our general life. So distance is the total length covered by you in a path, but without any consideration of the direction. You do not consider the direction at all. You consider the direction while moving from home to grandma's home and grandma's home to school and school to home. But at the end of the day, you have just traveled like, 12 meters. And that is what this distance is about. It does not talk about direction, it's a scalar quantity. And how do you measure distance? You add this individual distance. Even if it's small distance, like let's say you have traveled 2 meters upwards, 2 meters downwards, 2 meters upwards, 2 meters downwards, you're going to add them all. The total length covered in the path. Now we are talking about distance. Now the next thing is displacement. Of course you know that. So what is displacement? In more accurate terms, displacement is the distance between the final point and the initial point. Because final point is where you want to get to, and initial point is where you are or where you are traveling from. So displacement exactly talks about the distance between, not the distance actually, it's also about, that's the magnitude of displacement. It's about the distance between final point and initial point. So if you're talking about magnitude of displacement, then it is the distance between final point and initial point. And how do you find that out? You basically subtract, the coordinates or something, some value in the final, like the final point direction or final point position from the initial point position. And it's about the absolute length, that is required to reach the path. It should be the absolute length required to reach the path. So what about in this case? You went from your grandma's home, then to school, then back to home. What do you think is the answer? What is the displacement in this case? It's 0 because you're back to home. So now you haven't had a displacement to do that. You are back to home. You had a displacement, but that was just 0. So now the thing is, I've been talking about displacement. That means it should have a direction. So let's say I'm just going from home to school. Then I know I have to travel in this definite direction. That's how I get to the school. The shortest possible path. So displacement is also the shortest possible path between the final point and initial point. Okay, you need to critically remember this as well, because this is many definitions that is used in textbooks, and this is also to some extent true. I mean, it's the length between the final point and initial point, and it is also direction, and it is the shortest path. Now the thing is, we have been talking all about displacement. So this represents something like, difference between distance and displacement. You see, this guy started over here, he continued on all this path, he covered this path, he covered this path, he covered this path, he came back, he ended over here. So this is nothing but, the entire distance that he traveled. But whereas, if it was possible, he could have directly traveled in this direction in the shortest possible path, and you would have got to the end point. Okay, so that's the basic difference between distance and displacement. So distance is a scalar quantity, displacement is a vector quantity. It has a direction, displacement has a direction, whereas distance is positive and it does not have any direction. Now let's solve some problems around this distance, displacement and the concepts that we have covered in this class. And these problems are very important. Be attentive in these problems, because they will make your life easy, very easy. So a student walked 9 meters towards east and 6 meters towards north. So you're talking about cardinal systems, not about Cartesian coordinate systems, but we are talking about cardinal systems, the compass system. And a student walked 9 meters towards east and 6 meters towards north. Okay, and again walked back 9 meters towards west. He walked 9 meters towards west. So that means these two things have been cancelled out. So find the displacement between the path and the distance covered by the student. So what is the way to do it? You already sort of know, he traveled in both east and west by 9 meters, which means the displacement is only 6 meters. Okay, but what about distance? Distance is the entire length covered in that path, right? So that's going to be like 9 plus 6 plus 9. That's going to be 24. So it's going to be option D. And okay, just a moment. So there is towards south and towards north, isn't it? So you have to be specific about it when we are talking about displacement. Okay, we are not just talking about magnitude of displacement, we are talking about displacement. See, now you have numerically known that this is the correct answer, but what if both are like 6 meters? Which is the correct one? So he traveled actually towards north, isn't it? From the initial point, he has traveled only towards north. That means 6 meters towards north is the correct one. Now, this is a very simple one. Find the magnitude of distance and displacement between points A and B. This is something that we have done earlier. You know the answer very well, I guess. So now the thing is, what's the answer? Is it both the same? Of course they are same. And I've just kept it, like little confusing for you so that you're able to notice such things in your exam. So here it says, generally, you don't get things like this, but maybe in some exams you may get it. So one says the distance is 5 root 5 meters. The other one says displacement is 5 root 5 meters. And in this case, distance is 125, root 125 meters. And displacement is also 125 meters. So we are talking magnitude. Now the thing is, both are same, but both were given in the problem. So in this case, you may want to mark both C and D. Now the next questions ask you about find the distance and displacement between path A to B. So you are traveling from A to B, where B is the final point. So you have to subtract B from A. So A is not the correct answer, because displacement, in this case we are talking explicitly about the direction and we have been given vectors, and even though they are told the unit of vectors is metered, this is not the correct answer. Okay, this is not the correct answer. Now among these two, which is correct? We are talking from A to B. B is the final point. B minus A is equal to 6 I cap minus of minus 4 I cap, which is nothing but 10 I cap plus 10 I cap, and 8 minus 3 is plus 5 I j cap. That means this is the correct one. Alright guys, next one. Okay, this looks a little complicated to me. Tina walks 30 meters towards east, and then she again walks 20 meters towards north, and then 10 meters towards west, 50 meters towards south, and then again 10 meters towards west. Find the displacement magnitude and the displacement covered by the Tina. So this is like a very confusing problem. Like she's moving in multiple directions. I'm not able to figure it out. It's sort of very confusing. So is there an easy way to do this? Of course, we have been talking all about vectors and vectors. We are going to make use of vectors. to solve this problem easily. We can solve this problem in less than half a minute if you apply vectors and if you understood the cardinal system. See, one thing I can do is I can keep on drawing, assess which is the triangle, what is the hypotenuse of the triangle, and then, okay, this is minus 10, okay, then that would get lengthier. Rather, what I would do is I would directly write the I cap and j cap terms. So she traveled 30 meters towards east, which is plus 30 I cap, okay, and she traveled 20 meters towards north, which is again plus, but this time it is j cap, and she traveled 10 meters towards west, which is minus 10 j cap, and similarly she traveled 50 meters towards south and 10 meters towards west. South means negative y direction and west is again negative like x direction. So it's minus 50 j cap and minus 10 I cap. So if I wouldn't have told you and if you wrote it down in your exam, this would have been the fastest way to do it. This would have been did you realize that vectors made our life so easy when you're working around problems. So you must have understood the significance of vectors by now. So when I simply do this 30 I cap plus 20 j cap minus 10 I cap minus 50 j cap minus 10 I cap, you simply, do the, mathematics, and 30 I cap minus 10 I cap is 20 minus again 10 is 10. So it's plus 10 I cap minus 30 j cap. And you can simply find out the magnitude how we did before. It's under root 10 square plus 30 square, which is nothing but under root 1000, which is nothing but 10 root 10. So this is easier than drawing the hypotenuse, isn't it? I just wrote in terms of I cap and j cap and I just got the answer. Even if I had another direction, I could have done it, easily using this unit vectors or vectors in general. But now the thing is, we have understood all these concepts of coordinate system problem. We'll have a look at one more problem in this space so that we get a clarity. Raghu walks 30 meters towards east, 20 meters towards north and 10 meters towards west. So 30 meters towards east is plus 30 j cap. 30 meters towards east is 30 I cap. 20 meters towards north is 20 j cap, that is plus 20 j cap. 30 I cap plus 20 j cap minus 10 j cap. Minus 10 I cap. So it's 30 towards east is plus x, so it's 30 I cap. Towards north it is plus 20 j cap, and towards west it is minus 10 I cap. So that would be 20 I cap plus 20 j cap under root of 20 square plus 20 square. Okay, that is, here it is 10 meters, here it's 100 meters. That's the difference, okay? Here it is 100 meters and there it was 10 meters. So in this case, what would have been the answer? The answer would have been under root of 20 square, because east and west, they are in opposite direction, and that would be 20 square plus 20 square. That would have been and this is even simpler, 20 under root 2. Both are 20, right? 20 square. You just take them out. It will become so easy. So that is it, guys. Now we'll understand something, some topics that you may not be very interested in, but it is, crucial for your syllabus, be it even for your board exams. So we need to cover that a little bit, I know kinematics, vectors are very interesting, but we need to also cover that. But before that, we'll make it very interesting. Don't worry about it. So what is physics? Physics is very interesting, we know that, but what is physics? Heart of the science. Okay, maybe it is not, but it's a branch of science at least. So first we need to understand what is science. So what does Britannica says, science is nothing but a collection of knowledge with unbiased observations and systematic experimentation. So you need to do this unbiased observation. Science does not change from place to place. Units can change, some people are using some other units, but again, if you convert that units, it's the same thing. unless there's any external, factors acting on it. So science is like the absolute truth, that that exists. Absolute truth. It's the absolute truth. Like it's basically in terms that you may want to learn is like it's a system of collection of knowledge that is concerned with this physical world, this world. Okay, physical world means it can be also moon, but it is about physical world, the world that we can touch, feel, and etc. And it entails unbiased observations and systematic experimentation. So it must include unbiased observations. Again, you must test out these observations to make sure it works, because science cannot change from place to place. Science is like the absolute truth. You go in pursuit of knowledge, the first thing that will come to you, in front of you is science. And like, what does your NCERT definition say? Science is a systematic attempt to understand the natural phenomena in as much detail and depth as possible, which is true. In science, what you try to do is you're trying to understand the nature, the natural phenomena, why it is happening in as much detail and depth as possible. And you are trying to use this knowledge in order to do something, to exploit this phenomena, to modify this phenomena, to control this phenomena. You want to know, just science is not given to you like so that we didn't find science to just work around things like just know it and just keep it. You have to make use of it. You have to make use of this vector math. We have made use of this vector math, right, in like cardinal systems. Similarly, you need to make use of it. That's more important, and you must try to know things in as much depth and detail as possible. If you're really trying to pursue the knowledge, you'll try to explore things in as much depth and detail as possible. And you'd model the things, you'd create a model around it, you'd create a quantitative expression around it to predict, modify, and control the phenomena. So now, like, what does this definition specifically say is the same thing. Definition should not also change, but people have different perceptions, and it's like collection of too many knowledges. But science must include a systematic thing to do it, like a systematic attempt, systematic approach to understand the nature. So let's say I have a ball, it is falling down, then how do I know that it is falling down? Let's say in this case it was just a remote, but it's falling down. Why is it falling down? Okay, you need to understand this natural phenomenon. I'm not doing anything, I'm just dropping it, I'm letting it go through the free fall. And I'm trying to understand in as much depth and detail as possible. I can just say it falls on the ground, that's it, man, it's a layman term. But how do we do it? We need to know that there is something known as gravity. And we will try to understand this gravity in as much depth as possible. If I do this on moon, will it happen? Will it change? Will the speed or the velocity change? And why does this happen? So that is trying to understand things in as much detail and depth as possible. And we are having a systematic attempt to do it. So I'm going to drop it from the side, then I'm going to drop it from another side, I'm going to drop it from another side to assess what it is. Whether there is some external momentum coming from it, or whether it's the gravitational force, that I will understand it by doing such experiments. And it entails unbiased observations. It should not change from place to place, and you have to, you know this thing, you have gained this knowledge. Then you need to try to model it so that everyone will understand it. And using this, you'll try to predict things, modify things, or control things. Like control things in the sense, like what you'll try to do is you'll control the experiments to know whether it works, or you'll control the particular phenomena to develop something. Just like this, mobile phone or something that you want to develop. Now the thing is, what is physics? Physics is a branch of science. Physics is different from, rest of the branches of science, right? Physics is about nature. Physics is the absolute nature that you are seeing around. It's a branch of science that deals with anything, anything that is natural. And it is like deals with the structure of matter, how fundamental constituents in this universe interact. So two bodies, they have gravitational pull. This is defined by physics. And like every natural phenomenon, most of the natural phenomena that comes in your real life is defined by physics. It's a department of knowledge. So this is the NCERT definition. A department of knowledge which relates to the order of nature, or in other words, regular succession of events. Okay. A department of knowledge. See guys, if you see a very long definition and you think it might appear in an exam, the simple trick is to break it into pieces so that you can understand it very, very easily. Now, it's a department of knowledge. Science is also department of knowledge. So what is different from this? To define the order of nature, why the nature behaves in this way, why this, this particular thing that I was dropping is falling down. I need to, understand that order, like how does it do? And in other words, it's about regular succession of events. Like events after events happening should also show that order of nature. And we can broadly describe physics as study of basic laws and their manifestation in natural phenomena. Same thing that we talked earlier. We can describe physics as study of the basic laws of nature and their manifestation in different natural phenomena. So different natural phenomena, what I mean? For an example, I'm dropping this particular object on Earth. Then I'm going and dropping it on Moon. In both the places, it is falling down. It's basically because of gravity, I know that. But what is the difference between them? I need to understand that. I need to, try to, unify things or, or find some way to do it. Guys, don't worry. Even these topics are very interesting. I will make sure this also becomes very interesting. In the next lecture, at the end, we'll cover something known as how to propose theories. Like how to propose theories in science or, any other branch of science. Or in physics, like how to do that. Is there a standardized approach to do that? If you notice something, can you propose a theory? We will do that, we will do that. We'll at least learn the approach. We won't propose anything, but we'll learn the approach to do that. So guys, that's it for today. And now something more interesting. Share this channel, guys. Share this channel with others. Share this channel with your friends. Share this channel with your family. You know what? Share the knowledge. It is important that you share the knowledge. Power comes not from the knowledge kept, but from the knowledge shared. Like when you're brainstorming, concepts with your friends, you're learning better. When you're sharing the knowledge, someone will tell you, hey, this guy's lying, he's saying something wrong. So you'll come to know exactly about what is happening when you share the thing. So share this channel. Share this. It's a free channel. So share it with your friends. Share it with your friends who are in need of it or who loves to learn science or, any other subject of science, like chemistry, mathematics, or physics. And guys, take care. And if you love to, attend some live free classes with our top-notch educators, you can come to Unacademy Learning app, or you can also get a subscription anytime for your exam preparation and make use of my coupon to get a 10% discount and choose the program accordingly. I would recommend you get a 24 months program if you're preparing for, IIT JEE or something, or even for other competitive exams because they are 2-year long journey. Anyway, guys, stay safe. Take care. Bye-bye.